today I'm going to cover how do we solve real-world application problems, specifically using systems of equations. Now, if we weren't in this virtual online setting where we have to condense the curriculum, I would teach you how to do it algebraically. But we have learned in this class how to solve systems using matrices, specifically the RREF method within matrices. So our goal is to use that as a tool to solve the word problems that we're going to be presented with. Now, when we're presented with a word problem, we need to be able to identify what are the different parts, and we're going to define those parts with a specific variable and then define that variable. For instance, T equals the number of third place finishers. Then we're going to use that information to create equations. We'll solve the problem by putting it into a matrix and use the RREF method. And then we need to go back to the original problem to see what was the question and how do I properly solve it. Well, let's jump into this. So in this particular problem, we're talking about an amphitheater, and there happens to be three different parts here. Let me move this to the side so it doesn't impact us. Give me 1 second. There happens to be three different sections. We have the very front section here, we have the middle section, then we have the lawn section. And it says that the seats that are closest to the stage cost $30 each. We call those the front section. Then there's the middle section that costs $25 each, and last is the lawn seats. They're $20 each. There's twice as many seats in the middle as in the front. When all 19,200 seats are sold out, the amphitheater makes $456,000. Determine how many seats are in each section of the amphitheater. Okay, so remember, we were given these four different things. So we're going to start with how do we define the variable. So I see there's different types of seats. There's front, middle, and lawn. Let's do the obvious. F equals the number of front section amphitheater seats. M equals the number of seats in the middle section of the amphitheater, and L equals the number of seats in the lawn section of the amphitheater. At any point, if you need to press pause on this video, please feel free to do so. When you define this, what is not acceptable is F equals front seats, or M equals middle section, or L equals lawn. You want to be specific for it. The next thing we're going to do is, after we define this, is we need to create equations. So what do I know here? Well, they talk about the number of seats, and I can see that right, let me find here, right here is the number of seats. Okay, so I'm going to use those three variables I've defined, and it says to me that the front section plus the middle section plus the lawn section, when all filled up, there's 19,200 seats, and I'm just going to put seats off to the side so there's no problems there. Now next I'm going to put a dollar sign, because the next thing we are able to pull away from this problem is the cost, and it says that a front row seat, and that front section I should say, not front row, a front seat costs $30, a middle seat is $25, and finally those lawn seats are $20 each. And if they're all filled up with all 19,200 seats, those tickets come to a total of $456,000. Now we have one more part here we haven't touched, and that's twice as many seats in the middle section as the front section. This is actually the most difficult part of the problem for the majority of students. So let's just take a second and break away from this, and just to understand the concept, and I'm going to do that up here top. So up top here, I'm going to go over this. If I said to you, let's see if I'm able to nicely switch colors. If I said to you that you scored twice as well as your best friend, Y is going to be equal your percentage, and we're going to say that, so this is your score. It's going to be as a percentage. Y is your score, and your best friend's score is going to be best friend's score. And this is going to be on your chemistry test. So you have your score and your best friend's score. And let's go back here again. You scored twice as well as your best friend. Well, let's make this up. Let's say if you got an 80, that's you. If you got an 80, what would that make your friends? Well, your friends would have to be a 40 because you did twice as well. Well, how do you create that into an equation? Well, if the two sides had to be equal, you would say this. your score, if it's going to equal your best friend's score, and you had an 80% and they had a 40%, if they're going to equal, you'd have to take 2 times that person. So you're taking 2 times the smaller amount. The same thing applies here for this last part. If I'm able to go back, it says there's twice as many seats in the middle section as the front. So middle is here, and the front is here, and there's twice as many in the middle. So if these 2 sides are going to be equal, I need to take a 2 times the front. Let's come off to the side here just to make sure that works. Let's say the middle has 100 seats and the front has 50. If those 2 are going to be equal, we're going to be able to create an equation. I would have to take 2 times the front for it to equal the middle. Okay, so I've now completed step number 2. Step 1 is I defined the 3 variables. Step 2 is I created the equations. Now, step 3 is I'm going to write down, what does this look like as a matrix? Well, remember, in front of each of these variables is a hidden 1. 1, 1, 1, 19,200. That one's already organized. Awesome. I can see this one's organized too. It has the F, it has the M, it has the L, and then it has the constant on the opposite side. Here's the problem here with this last one. F has to go first. So if this F has to cross over the equal sign and go all the way over here, remember, when you're moving something by adding or subtracting, when it crosses over the equal sign, it changes signs. So it was a positive 2F, but when it comes way over here to get in line with the F's, it changes signs. And now it's moved to the other side. There's nothing left over here. So I have a negative 2F. When I line it up, I have a 1M. There's their M's. I see no L's in this problem, which means I can't leave it blank. I have to put a 0. And there's no constants because the 2F is moved over. This is what I want to plug into the matrix calculator. So what do I do next? So I'm going to press pause here, and I'm going to pull up the matrix calculator for you. Okay? Now, on the equation we just had, we had 3 different equations. The first was talking about seats. The second was the number of seats specifically. The second was the cost. And the third one was the comparison between the middle and the front, the number of seats in the middle and the front. So when I create this new matrix, there are 3 equations and 4 distinct columns. The F for front, the M for middle, the L for lawn, and then the constants. So I'm going to type in what I had down, and I happened to write that down before I went to the screen. Then I come down to the very bottom here, I press enter. I've programmed in matrix A. Right here over the top you can't see it, but over here we have an RREF. Again, this is matrix A. Now what does this mean? So I'm going to write down these numbers. I'm writing down 3,600, 7,200, and 8,400. Remember, on the very far side here, this represents the first variable in my first line. I had an F, and then the M, and then the L. By the way, I need to switch those variables for next semester. So forget about it being an FML. Okay, so over here, that means that the front row has 3,600 seats in this amphitheater. The middle row has 7,200, and the lawn seats there is 8,400. Now, step number 4 says, step 4 was answer the question. I've highlighted the question. I strongly suggest you do the same when you get to your exam. And you may be wondering, how can I highlight on the test? Actually, within Illuminate, that is one of the things they allow you to do, is highlight the text as you go through it, actually on the screen. So determine how many seats are in each section. Okay, so again, I came up with an answer of 3,600, 7,200, and 8,400. So now, I need to write that down as a complete sentence. That's very important. So here's my complete sentence. There are 3,600 seats in the front section of the amphitheater, 7,200 seats in the middle section, and 8,400 lawn seats. That would be the first example completed. The second example for the thrill secrets of the world. I love roller coasters. So this one says that Diana goes to the amusement park to ride the roller coaster, bumper cars, and water rides. The wait for the roller coaster is 1 hour. The wait for the bumper cars is 20 minutes. And the wait for the water rides is 15 minutes long. Diana rode 10 total rides during her visit to the amusement park. Because she enjoys roller coasters the most, the number of times she rode the roller coaster was the sum of the time she rode the other 2 rides. If Diana waited in line for a total of 6 hours and 20 minutes, how many of each ride did she go on? That is just a lot of information. So let's first stop. Remember, step 1 is, what are they talking about here? Well, they're talking about 3 kinds of rides: roller coaster, bumper cars, and water rides. Okay? So I'm going to define those as R is the number of times she rode a roller coaster, B is the number of times she rode bumper cars, and lastly, my W is the number of times that she rode water rides. That's step 1. Step 2 is you have to somehow come up here and write an equation for this. So let's go slow it down here, and it's talking about a few things. It tells me here, and if I go back and hit on this, and I'm going to highlight, that will just help myself here. It tells me that she went to a roller coaster, waited for, so it tells us about how long. Here we go. She went on a total of 10 rides. Okay, so I know here that, I'm going to do this one just in maroon. I know that roller coaster, bumper cars, and the water rides, in all, she went on 10 rides. So one thing they talk about is the total number of rides. The second thing I'm able to pull out of this problem is discussing, well, how long? How long is it for each ride? So I can see here's your roller coaster, here's your bumper car, and there is the water ride. Okay, so I have that down, and it says, I got to keep going here, and it says those combined, she was in line for a total of 6 hours and 20 minutes. Okay, so I'm going to now go here, and we're going to go to a pen, and I have, okay, for a roller coaster, it's 1 hour. But here's the problem. I see one of them has units of hours, and the others is minutes. Okay, well, in my mind, I can easily convert 1 hour is 60 minutes. So I want to switch that up so it makes sense here. So I have 60 minutes to be in line for a roller coaster, 20 minutes for a bumper car, 15 minutes for a water ride, and then it tells you 6 hours and 20 minutes at the very end. But I need it all in terms of minutes. So I know that each hour is 60 minutes. So really this is like 60 plus 60, a total of 6 times, because each hour is 60 minutes. So 60, 60, 60, 60, and 60, 60. That's 360 minutes just from this part. You add an additional 20, and you're up to 380 minutes. Why am I converting? Because they all have to be in terms of the same unit. So I put them all into minutes. Now the last part here is talking about this comparison. And it says here that because she enjoys roller coasters, give me 1 second please. Because she enjoys roller coasters the best, thank you for your patience, it says that she actually went on roller coasters. She went on roller coasters a lot more than the other 2 rides. In fact, the number of times she rolled on a roller coaster was equal to the sum. That means equal to adding. It was equal to the sum or adding the other 2 combined. So that looks like roller coasters, the number of times she rode them, is equal to the other 2 combined. I'm saying combined because sum means to add. Give yourself a second, please, and I want you to write down, put it on pause, and write down these 3 equations. So, a little bit neater written. This is the number of rides. Once again, this is the number of rides. This is the time she waits, and this is the comparison of the number of times she rode a roller coaster compared to the other 2 combined, bumper and water rides. Now let's put this into an equation. Okay, so I see R lines up, B lines up, W, and a constant. Remember, the numbers in front are 1s. So 1, 1, 1, and 10. 60, 20, 50, 15, and 380. Now R has to go first. Well, R is already over here. That's awesome, okay? But then the B has to come over to the other side because it has to line up and go R, B, W. So when the B is a positive 1, it crosses over the equal sign and it goes to the other side. It becomes a negative 1 and it disappears on the right. Same thing with the W. It's a positive 1W, but it needs to be on the opposite side. So when it joins the other variables and comes across the equal sign, it becomes a negative 1W. Remember, we don't put into the matrix the actual variables R, B, and W. We just put the numbers in front. And then now that these two have joined the left-hand side, there's nothing left over here. Give yourself a second, please. Okay, here's what we have. Now, how do we convert this into a matrix? 1, 1, 1, 0. Again, I'm just going over how we did this. Most students, I know I did this on the previous slide, most students are able to easily do the first two because they're already organized. It's this last one. So 1, negative 1, negative 1, and 0. I'm now going to switch and move over to the matrix. If your previous problem was here, if you hit clear all a few times, it will go away. So we had 3 equations, that's 3 rows, and again there are 4 columns. It represents the roller coasters, that's 1, the B and the W, and then we have the constants. Now I'm going to plug in the numbers I have. And I come down to the bottom right to press enter. So I've programmed in that particular matrix, and I can't see it well. Let's see if I'm able to make this a little bit smaller so we're still able to work with it. When I hit RREF and I go back into this matrix, I see my answers on the right. Now I need to write those down. I have a 5, a 1, and a 4. What does it represent? Well, if I come back to this one, I can see that the R was the first, that was the first variable. So that means she went on 5 roller coaster rides, she went on 1 bumper car, and she went on 4 different water rides. How did I know that? Because remember, I got answers in the matrix, of 5, 1, 4. Again, you put it into a complete sentence, and this problem will be done. Let's go into the last one. That is the most like the test question you will have in the coming days. Okay, so Tolleson prevailed in Saturday's track meet with the help of 20 individual event placers earning a combined 68 points. That means 20 individuals from their track team, 20 event placers. That could be that some person gets first place in multiple events, but there was 20 different medals. If you think first, second, and third got a ribbon or a medal, this particular track team was given 20 different prizes for those places of first, second, and third. And those points that they earned for their team by placing first, second, and third added up to 68 points. It says that first place earns 5 points, second place earns 3, and third place earns 1 point. If you're unfamiliar with track and how it works, each team, individuals, yes, they want to do well, but it also works as a team sport. And so if you place, for most track meets, it's in the top 5, but this particular one only talks about the top 3. So in this case, if you place in the top 3, you earn your team points. And again, first place is 5 points, second place is 3 points, and third place is 1 point. And at the end of the meet, they'll have a boys winner, a boys team that wins, and a girls team that wins based on who is able to get the most points. To continue on, it says that Tolleson, I have a T in there accidentally, has a strong place. They have as many second place as the first and third combined. Oh, that's kind of like the last problem, where the last problem said they went on as many roller coaster rides as the other 2 combined, bumper cars and water rides. Very similar. How many athletes earned first place finish in Tolleson's track team? Okay, so we got to think about what do we have here. And you're going to write down this. At any point, feel free to press pause as you go through this. So it's talking about first, second, and third. So I'm going to put F equals number of first place finishers. And that's from Tolleson. And okay, their second place. The second equals number of second place finishers from Tolleson. And T equals the number of third place finishers from Tolleson. Now we're going to go ahead and we are going to actually come up with those equations. So I have F, S, and T as defined variables. Okay, so let's dive into this together and let's see what this looks like. They talk about how many points and how many actual earned first, second, and third. So first, second, and third. If each one of those is going to get a reward like a medal or maybe a ribbon, it says a total of 20 was given to this team or was awarded. But then it says those 20 earned the team 68 points specifically. And how did you do that? Because first place gets 5 points, second place gets 3 points, and third place gets 1 point. Now way down here it says they had a strong finish with as many second place finishers as first and third combined. Second was equal to first and third combined. How can we put this into a matrix? Well, the first part again is pretty easy. Remember the numbers in front here would be 1. So 1, 1, 1, and 20 all lined up. Again, F, S, T, and the constant. Now in this case, F has to go first. It's on the wrong side. When it joins the others and it comes across, it becomes negative, and it no longer here is on the right. Next has to be S. I can see there's a 1S already that exists on the correct side. And now the T needs to join it and go right here to line up. Again, it was a positive 1. When it crosses over the equal sign, it becomes a negative 1. And now that it's crossed over, there's nothing left. Please write down this matrix. Press pause if you need to at this time. I'm now going to go to the matrix calculator. So again, I have a 3x4 I have 3 equations in 4 distinct columns. I'm going to plug in the numbers that I created. So it was a 1, 1, 1. And as I pull this up here, give me 1 second to look what I wrote down on my piece of paper. Thank you for your patience. 1, 1, 1, and 20. Then it was 5.31 with a total of 60 points for those 20 event winners is the first one. And when I reorganized, I came up with this. Okay, again, we're going to hit enter, and I'm going to make this a little smaller so you can see it. I hit RREF. This was matrix A, and what does this information mean? So it says 5, 10, 5, 5, 10, 5. Let me go back to this previous screen. 5, 10, 5. Okay, so 5, 10, 5. Well, that means that 5 is going to be, oh, excuse me. Thank you again. I'll just leave it on this screen when I answer the question. So F is the first one. That means F represents 5. There's 5 first place winners from Tolleson track team. The next number was 10. It means there's 10 second place winners. And again, 5 was the last number in that matrix, so there's 5 third. Okay, and it says how many athletes earned first place. I'm going back. Step 4 is always answer the question. How many athletes earned first place finish from Tolleson's track team? Again, F stands for the number of first place finishers, and that answer was 5. If you need to rewatch this video, please do so.